Hello everybody, we're going to be putting together the board stack of this Xeltek Superpro 6100. Yes, this cover says 6100N, but the actual hardware is 6100, and on the bottom plate, I'll show you at the end, is a 6100. In reality, actually, this is a 6000. You'll see the assembly video pictures on the blog of the 6000 and the 6100. There's not much difference, I think, other than brand of memory and the identification chip. All the other parts are identical. From a 6000 to a 6100N, it's the software. It's how the manufacturer uses this chip to tell the software, I'm this programmer, work. So, but let's go ahead and assemble this and show you up close and personal the parts. There's not much difference from the other ones, so it's kind of a redundant video. I wish the manufacturers would provide schematics, so when there is a model number change, you can look at the schematics and see the difference. You know, customer transparency, maybe. You know, consumer protection. That would be one way to do it, to prevent these companies from taking advantage of customers by shady stuff like that. Change one identification chip and say, oh, we're not going to support that programmer anymore with updates. Change nothing else, and say, you got to buy another $1,000 programmer. And all it is that chip right there. That chip. This little tiny chip. Come on, man. You know. But the 6100 and the 6100N, they did hardware changes. So let's go ahead and go through them. So this is the ground driver board. Of course, it's dated 2007-08 with a manufacture date of 2014, 32nd week. Maybe. Okay. Let's see if we can focus in here. If you guys spot any difference, if you want to go through and watch these videos, let me know. Let's go this way. These are Hyros FX2 connectors. I forgot to mention that in the other videos. They're widely available. But I think the serial number on this programmer was made in 2016. So it's fairly recent. It qualifies under Oregon right to repair. I have made my schematic request. Xeltek's a really good company. I've really never had a problem with them. I know they've denied right to repair. They're actually Xeltek America's EXP computers, operated by Sunam Kim. So that's the ground driver board. They're really good people there. I've really never had an issue with them. Everything generally gets referred to China. If you buy a Xeltek from like HKLRF or off of AliExpress, be aware China will not support it if you are from America. And that's the problem I have with Xeltek. China will say, oh, well, we're not going to give you support for that. So, but if you're in Europe or whatever and you buy a Chinese one, you'll get support for it. They'll refer you to Xeltek America, and the Xeltek America will say, oh, you didn't buy it from us. It's not in our serial number database. It don't have a holographic seal. You need to contact China. So, that's the situation with the programmers. That's why I recommend anybody buying a Xeltek that's in the United States, spend the extra $230 and buy one from Xeltek USA, because if you need to make a device request to have a chip added, whatever, Xeltek America will facilitate that in English with great speed. I've never had any problem with their customer service. So, but the Xeltek China company, we're trying to figure out the right to repair in Oregon here. It's going to be interesting. You have some sort of like a Hoog or whatever convention to be able to have even the Attorney General do stuff in foreign countries. So I think that's where the framework of the right to repair laws is going to fail us, is with the foreign countries and their rules. So, okay, that's 6 minutes of me just blabbering here. So the next board will be the V3. That's the voltage 3 board. That's this one here. And this one, again, 2007-06. Some of these reflect the light really well and get good info on the chip numbers. Some of them are just not that good. This one's doing real well. They are really, really, really simple. Like I said, anybody with a multimeter could probably reverse engineer this pretty quickly. I don't have the time or the patience to do any reverse engineering. Again, make sure it lines up, everything's seated. That one don't want to push in. I think this one was the one that was a pain in the butt to take apart. No, that one don't want to push in. Make sure I didn't bend a pin. I just think it's the connectors are tight on it. Oop. What is that? We got foreign debris. There it goes. A little tight, but yeah, this one was a pain in the rear to take apart, if I remember. I know one of them was super pain in the rear, but just always, if you're putting these together, just stop. If it gets tight, make sure that was a V3 board that I put on there and mix it up. Yep, V3. Okay. I don't know what would happen. That almost went to the 5th dimension. That would have been bad. I don't know what would happen if you put these together backwards. You know, put the board in the wrong spot. Maybe I can sacrifice a 5000, that 5000E for an experiment and do that. I don't know. Probably blow it all up. If we had a schematic, we could pretty much tell. You know, we could go through the circuitry and say, oh, yeah, if we put this board to this board, we'd be putting a ground to a power, and or signal line to power or something. But no, we don't get no schematics. We're not that lucky. Cotty wants cookies, so you're going to have to keep cookies off camera, okay? Okay. Next board would be the V3172. And again, this is a 2006, 2014, 33rd week. And I'll just go through this real quick. I don't see any difference between this one and the 6100N. If you guys spot a difference, point it out, make a comment. But I don't see anything different. Yeah, I think this is the one that was very hard to take apart. That one goes in much better. A little tight on that end. All right, we're in there. Yeah, serviceability, very tough if you're having to diagnose. But their diagnosis in the software's pretty darn good. And you don't need to wrench those down super tight, just snug, just good enough. Next board is the V1. This board right here. And again, this has a 2007-08 date and manufacture date 2014, 32nd week, I'd assumed. And same amount of transistors, different resistor packs on these boards. I mean, I've gone through and, you know, taken capacitors off for people and measured them to get people up and going. So not much to that board. Let's drop that one on here. Yeah, I wish they would have used brass. Would make things, because the plastic, they're a little bit bigger with the holes. So, okay, we're Went in nice and easy. That stack is coming together. Now, if you like these long teardown videos, let me know. If you can think of any improvements other than more Coddy, because we know everybody likes Coddy. Let me know. I'll try to accommodate. But yeah, I think Xeltek USA, they offer service on these. And it's kind of like a flat rate, couple $100 or something like that. So okay, next board would be the V1. We just did the V1, right? I think I got lost on that one too. Yes, V1. Next is the V2. I could have laid these out in order so I wouldn't fumble like that, but oh well, I'm human. 2007, 6 month or week, 1432. So I'm going to assume again that is 2014, and 32nd week is when this board was printed. And yes, it is a print. It is once a board is printed and in the public, it loses the schematics and what lose trade secret protection is what I've been told. So if they've got, a prototype and they've manufactured it and it hasn't been anywhere other than the factory, that's oddball. They had a different... Okay, that's just a different chip. I was like, is that a different different chip in the same series? But no, it was a different manufacturer. But yeah, so once you make it and put it in the public domain, there is no secret anymore. So, again, if you see any difference other than, that date, let me know. Comment. I don't see any difference. So, we will throw this board on the top. Or on the bottom. Because this technically is the top of the board. And it goes down. Okay. That one wants to be stubborn too. I think this was the one that was difficult to take apart. I don't think they got everything lined up perfectly on their connectors. Okay, there it goes. A little bit of force, but nothing binding. So, getting there. I need coffee. But I have to get these programmers back up and going. I got work to do Friday. So you probably won't see these until after Friday, or maybe Friday. We got Cotty over here purring. You hear her purring. She's happy, kitty. So when I'm done with these, I'll go through and give you my opinion on all of them and give you my recommendation on what programmer to buy, because I get a lot of questions asking what programmer do I recommend, the 6100N or the 7500. And that answer is it depends, and I'm just going to give the answer right now. If you're just doing basic older stuff, 6100N. If you're doing more modern bleeding edge technology to where you want to, develop modern with, or use modern NAND and everything, then you go with the 7500. If you want to deal with ARM chips and in-circuit programming, I recommend the ISO1 and the Surger Flasher Pro. You have to pretty much have both. So next board is the I/O board. And this I/O board, again, 2007-06. So that's either the 6th week or June of 2007. I don't see my stomach. I don't see a manufacturer date, but Xilinx guys, there you go. Same thing. Remember, this is the non-in, but they changed the resistors and added capacitors in this neighborhood. So they did something on the 6100N that they didn't do on this one. So I'll zoom back in and you guys can see. Okay, let's put this back. Let's put this on the board stack. It's like building a programmer wedding cake, man. Yeah, I think they're off on these connectors slightly. I can see it kind of curving in that way a little. So that's manufacturing flaw. And we get the MCU board. Yeah, people wonder, they go, oh, well, the little XEU, whatever, $100 thing from AliExpress. They're like, oh, that's the ultimate programmer. That's the ultimate programmer. Man, that thing don't even have a full 48-pin pen driver in it, man. It's, yeah, if you want to do, the most common SPI, EEPROM, flash, it's fine. But if you get into some weird stuff, they don't cut it. Then there's other like consumer programmers that are, you know, device specific. So if you go with the device specific ones, then you end up with a whole friggin' box of programmers, and you got to figure out, okay, do I have that one or not? These are pretty much universal. Sometimes you still have to get device specific because they have not been added to the Xeltek yet, and it costs a couple $100 to add a chip. So it's either pay the couple $100 to, like when UPDI came out, it was a couple $100 to add that, or almost $1,000, and it's like, okay, well, I can go buy a UPDI programmer from Microchip for, $75, $150, so no brainer there. And then 6 months later, Xeltek adds UPDI, and all the other programmers follow suit. So that's the way the industry works. So the bleeding edge technology is usually reserved for their flagship programmer, which now is the 7500. So let's look at this MCU board. Quit babbling there. Okay, this MCU board, again, not sure what the battery does. It must back up something somewhere on here. I haven't dug in deep. So I'll zoom in here. If you see, that's still 2009. 09, so is that September 2009? Or 9th week of September? Same chips. Still not sure what J1 is. It's on my list. I asked about the battery, but I didn't ask about J1. There's their AE81. That's most likely a masked AC-tel chip, or it could be a Xilinx or an FPGA of some sort. And you've got the AE801 on the 6000. This is a 6100 non-N. On the 6000, that AE801 is an AE80. And on the CX adapters, they used an AE80. And then when they went to the DX adapters, they went to the AE801. So I think that is the only difference between the 6000 and the 6100N. And this header, I'm going to assume, is a programming header for that. This unpopulated header, I think it's going to be for the Atmel. Then you've got your SPI flash right there. Come on. Same flash. RC16, off the top of my head, I don't know what that is. I should have looked it up, but and the only other difference was the all the capacitors looked like they were larger voltage values. So I'm wondering if they had issues with them. And up the voltage value. I don't know. Or maybe they just messed up in production. So let's get this board on, and then we'll go to the power supply board. Oh, I did try to back that up in circuit. Nope. I'll eventually come back and revisit it, and that's the chip that holds the firmware. So I will back it up because of their anti-repair. So if they won't provide it, we got to get it somehow. But that, I did look that chip up. That chip can be secured. So I'm just still curious. I want to put a jumper on there. I just so badly want to pop a jumper on there. Okay. Let's put the little washers on there. Should we give Cotty some cookies? I think we should. Here, Cotty, get some cookies. Here, what's this? Cotty gets cookies. She's been very, very patient over there. She just sits there and watches me all day. I don't know, man. I don't do anything interesting, so. You know, we sit there and watch our animals, and our animals watch their humans, I guess. So, I was going to testify this week on Right to Repair, but I just decided I'm not going to. I have other things I'm busy with in my personal life, so they take precedence. But I have to get this done. This has been on my to-do list for like 2 years. So, oh, the date on that MCU board was 14/32. Looks pretty consistent on this one. And the other ones are all over the place. So. And we get a QC Pass sticker. Yes, we do. Okay. And we have the power supply board. Nothing unusual on this power supply board. I haven't seen a 6100 or a 6100N yet come in with a bad 470 35 volt yet. But here's all the parts. You guys can reverse engineer this from a video, so be it. VR3 is one regulator, VR2 is another, VR1's another. If you reverse polarity this, you kill Q4, Q2, Q5, Q6. Those just get nuked because these are center negative, which is an oddball. I'm sure Xeltek has made a lot of money on people reverse polaritying these. And 2006 on the back, 14/32. So we're almost done here. Get all those pins lined up. Drive it home. Oop. Gotta show that. Last standoffs, then power cable. Yeah, I should inquire and see about becoming a Xeltek service center, just to see if they'll discuss with me a little bit more on obtaining schematics and service information. Because these are expensive. These are, $1,000. It's Make sure all all the standoffs are flush, nothing's floating and twisted. Yeah, I mean, if somebody wanted to convert it to center positive, you just have to flip these. I think. Nah, maybe not. I don't know. I'd have to look into it a little bit further, but there we are. We are assembled. Now I'll put it all back together, and I'll power up these on another video. I'll line them all up and power them all back up. Show you they all work. I believe Alex, the creator of the Magic Chip, already backed up the firmware on the 6100N. I think that's already public. So we have, for screw-wise, show you this is the 6100 right there. Non-N, even though it says 6100N on the front. And this is the deception you get with the Chinese sellers too. Because there's a lot of the 6100s on the Chinese market. I mean, it's got Chinese writing up top there. They'll sell them as a 6100N, but they're actually a 6100 because the 6100 works with the 6100N software. The software detects it as a 6100N. So, but it's the exact same hardware, identical to the 6000. So, thanks for watching. If you like this content, tell me. If you don't, tell me. But if you really like this content, this is expensive. Check out the blog. Give a super thanks. Thanks for watching.